Alright, so in this clip we'll talk about the Emit command as well as the particle collision geometry index. And this will also help you in solving the problem of emitting the secondary particle with respect to a particular passive collider. So let's begin with a very simple scene. Let's go inside the nParticle menu and create the particle emitter. Reposition this Omni emitter and play the timeline. So here we have some particles. Change the type to the sphere for better visualizations, as well as the color to maybe red, and use the ground plane. Now let's create a very simple sphere for the passive collider, rescale it and reposition it. So let's go inside the enclose and use the create passive collider. Make sure we have the same nucleus. Hit this option. And now once we play the timer, you can see particles simply interacting, sliding and colliding with this passive collider. But before we proceed to Emit command, let's first talk about the collision geometry index. Well, this unique per particle attribute, which is the collision geometry index, will give you the access to identify the unique ID of the particles at the time of the collisions. And this particle ensures that for every different passive collider, you have a different ID. And with the help of this, you can control the particle secondary collisions. So let's take a look inside this by going inside the nParticle, per particle attributes over here, and let's go to the add attributes. In the general, we have the particle tab and click the collision geometry index. Click the option OK. Now we have the collision geometry index PP attribute. Now go inside the particle render type, change this to the numeric, and as you know, we'll type the collision geometry index, and we have collision geometry index, and make sure you type correctly. The C is small, the G for the geometry, and index is capital. Now hit the enter and notice carefully, the -1 value indicates that there is no collisions at all. But if you just increase your frame, you notice some of the particles are showing the ID of the 0. Well, these are the particles which are now under the collisions with this passive collider. So it simply means that Maya has assigned the ID 0 to the particles for this passive collider. Alright, now what if in case, let me just reposition this. Let me just have another, let's say, a passive collider, and let me just rescale this, hold this over here and go for the passive collider. Now you notice the moment particle collides with the smaller one, they'll give the ID of 1. And let's play the timeline and notice here we have the ID 1 and here we have the ID -1, which means the particles under no collisions, particle with the collisions. And now if I continue to play the timeline, you'll notice here we have the ID 1, and over here if I play the timeline, we have the ID 0. So this is something really very fantastic. And if you just keep creating different passive colliders, Maya will keep adding the numbers to create the unique ID. Alright, now that was really nice. So let's bring it back to the sphere. Alright, and now let's just do one thing. Let's frame our statement, or let's frame our expressions. And now my question is that once the particle hit this geometry 1 or geometry 2, the secondary emission of the particle should take place only and only from the bigger passive collider, and this can be possible if we use the emit command. Alright, so let's do one thing. Let's type our statement. So let's go inside the collision geometry index, go for the create expressions, and since we want to affect the scene for every single frame, so we have to use the runtime after dynamics. Alright, now let's just bring it over here. We have nParticle shape 1 dot collision geometry index. Let's prepare the statement. If we have the if the nParticle shape 1 collision geometry index equals 0, then we have some statements inside this. So the first thing is that we want particles. Of course we want these secondary particles. So the moment secondary particle, appears, or they just start emitting from the collisions, what exactly the important thing is their position and the speed, or you can say position or their velocity. So let's talk about their position. So let's say we have a vector $pause, a variable that can store the position of the primary particles, or you can say the parent particles, and will inherit the position of the parent particles to the secondary particles. So for that we are framing this. So vector $pause equals to the nParticle shape 1 dot position. Very nice. Here we go. And now let's talk about how many particles we actually want. Maybe we want the particles 2, 3, 5, 6, whatever is the number. So let's create a random expressions where we can give, for every single collisions, let's give a random number. So let's say we have a integer int dollar, let's say birth, and equals to a random value, let's say 2 by 6. There we go. And now let's create a for loop that will helps us in repeating the process of particle emission with respect to the emit command. So let's do one thing. Let's have a for loop, and let's have the $I equals 0. And this is, most of the time we actually frame things inside the for loop because we want the repetitions of a particular command, that is the emit command. So here we have the $I, which is obviously less than the $birth, because now we are treating $I as a 0. So 0 is obviously less than any random value, maybe 2, 3, 4, 5, whatever it is. Okay, and we have $I plus plus. So it means till the time it reaches to a value which is bigger than the birth, only then this loop will stop. And inside the loop we are giving some few things, and that is the random velocities, because for every single particle emissions we want a different velocity. So let's have the vector $val equals to the, let's say we have a random value 1 comma minus 1, and that is the velocity for the x-axis. Let's say we keep 0 for the y-axis, and let's say we have a ran for the z-axis velocity, let's say 1 comma minus 1, and here we go. Nice. Now let's bring the emit command. Alright, so we have the syntax for the emit command, and that is emit object. You can type any name for the particle. Let's say we have the point, which is the name of the particles, the position where exactly it has to appear, and obviously that has to be $pause.xyz. So let's say we have the $pause.x followed by the $pause.y and followed by the $pause.z. Alright, and let's say we have the attribute velocity with the vector value, which is the $val.x, and we have $val.x followed by the $val.y, and finally we have $val.z. Alright, so I do one thing, I'll take a pause over here and continue this thing in the next clip.